This video is just to show how you should, or how we expect you to answer the questions in activity 17.5 on page 391. And as we go along, I'll also go through what these things are so that you know what to look for and what it is. Okay. So there are 5 questions on this page, and for each one of them, you have to do A, B, and C. So A says draw a Venn diagram illustrating the events A and B. B says write down the probability of event A, the probability of event B, the probability of their intersection, so A and B, and the probability of their union, probability of A or B. C asks you to check that the probability of their union is equal to or the same as saying the probability of A plus the probability of B minus the probability of A and B. Okay, so let's actually look at a question. So I've taken one that we aren't expecting you to do by yourself. Okay, and it's called question 2 on page 391. And it reads the following. The sample space is the first 6 letters of the alphabet. So before I even go further, I'm going to write down what that sample space is. So let's just move my text box. Okay, so my sample space is the set S, which has the following elements in it. Remember, we use curly brackets to show a sample space list. So it says the first 6 letters of the alphabet. So A, B, C, D, E, and F. So it's 1, 2, 3, 4, 5, 6 letters of the alphabet. Then it goes on to say that event A is choosing a vowel. So from my sample space, I need to identify whether each one of them is a vowel or not. Is A a vowel? Yes, so it belongs in my event A. Is B a vowel? No, so it doesn't belong. Is C a vowel? No. D? No. E, yes, so it belongs in my event A. Is F a vowel? No. So now I have defined my event A as the vowels, and the members or the elements in A is the letter A and the letter E. Please note that I'm using small letters so that I don't get myself confused between the members or the elements inside the set and the set that's actually called capital A or capital B. Now I'm also going to do the same with B. Now B is consonants, so those are words that are not words, letters that are not vowels, okay? So A is a vowel, so it cannot be in this list. B is a consonant, so it's in this list. C is a consonant, D is a consonant, E is a vowel, so I can't put it in this list, and F is a consonant. Okay, so I've defined my sample space as all of the first 6 letters. I've defined my event A as only vowels, and I've defined my event B as only consonants. Now let's go and actually do what they ask us. They tell us to do a Venn diagram. So let's just take this up a bit. They say there, draw a Venn diagram. So I'm going to do that. I am drawing with a mouse, so please excuse if it's not as tidy as it could be. So I'm first going to draw a big block representing my sample space, and my sample space in some form or another should include all the letters from A to F, okay? So it should include all 6 elements. So that is my entire sample space, and I'm going to call it S. Now let's do A, event A. So the entire set I'm going to represent using the red circle, and I'm going to call it A, okay? And A has got the letter A and E in it, okay? Now when I draw B, I need to consider if there's any overlap between these 2 events. And I can see that they do not share any letters whatsoever. So when I draw my second event, I am not going to show an overlap. There cannot be anything crossing over because then you're showing that they share something, but they do not. So I'm just going to draw a second circle on the side here called B. And B has got the following elements: little b, C, D, and F. And there's my Venn diagram. I have represented the entire sample space and both events A and B. The next part of my question asks me for the various probabilities. And in order to do the various probabilities, I need those various formulae. Okay, so I'm just going to copy over those formulae quickly. Okay, so since question B asked me for the probability of A, probability of B, probability of A and B, and the probability of B, A or B, I went and wrote down what those different formulae are. So in general, the probability of something is the number of times you get a successful outcome, and compared to the number in the sample space, so you divide by the number of the sample space. So it's the number of the event, or how many elements are in your event, divided by how many elements are in your sample space. So for event A, it would be the number of elements in A divided by the number of elements in my sample space. So we've already defined my sample space as A, B, C, D, E, F, and there are 6 elements in my sample space. And my event A is the vowels, and that is 1, 2 elements. And with every fraction, we have to simplify. So the probability of event A is 1/3. Okay, and I do the same with B. I'm looking at how many elements are there in my sample space. Okay, and how many of those elements are in my event B? There are 1, 2, 3, 4 elements in event B, and I simplify as 2/3. Now, I need to go and do the operation of an intersection, okay? That means I must list all elements that have A and B together in them, okay? And what I've done here on the side, if you want to rather do all the different ones in the first place, then you can do that. So how many are in my sample space? Well, there's 6 elements in my sample space. How many elements are in A? There's 2. How many elements are there in B? There's 4. How many do they share? Now, can a letter be both a consonant and a vowel at the same time? And the answer is no, it can't be. Okay? So there is nothing that they share, and therefore there are 0 of them. Then I'm looking for the union. All letters that are in A or in B or in both of them. Okay, so I'm essentially looking for all 6 letters. And what you do with this is you just substitute in wherever your equation is. Okay, so let's continue. So A and B, like I said, there is nothing, it's not possible to be both in A and B at the same time. Can't be a consonant and a vowel. So I have 0/6 total options, and that just gives me a probability of 0 if I have to simplify. Lastly, like I said, how many are there in A or B? Well, there's 6 of them. And how many in my sample space? There's 6. And lastly, to simplify, 6 divided by 6 is 1. So they have completed B, okay? Now for C, they asked me check that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, okay? So I'm just going to copy that. Okay, I'm not going to copy it, but what I want you to notice with this kind of question is when we have to check if left-hand side is equal to right-hand side, we do exactly that. We find what the left-hand side would be equal to. Left-hand side. And my left-hand side is the probability of A or B. Now, from our calculations, we know that it should be 0. Not 0, sorry, A or B should be 1. Now let's check right-hand side. My right-hand side of the initial question is that I must calculate probability of A plus probability of B. Let me just move the screen up a bit because I'm going to need it. Okay. Probability of A plus the probability of B. I do apologize for the untidiness. It's not easy writing with a mouse. And lastly, the probability of A and B is minus. And now I substitute in what I calculated those probabilities to be. So probability of A I calculated as a third. Probability of B I calculated as 2/3. And the probability of A and B I calculated as 0. So 1/3 plus 2/3 is 1, and 1 minus 0 is 1. And therefore I can say left-hand side is equal to right-hand side. Therefore, left-hand side equals to right-hand side. And just to finish it off, and I'm going to put this one in text, you can actually say what they have asked you to check. They asked you to check, is it true? And now by saying therefore, you're saying that yes, it is indeed true. What am I saying? I'm saying that the probability of A or B is equal to the probability of A plus the probability of B minus, take out that extra bracket there, minus the probability of their intersection. Okay, so you're going to do that with each one of those questions that they asked you to do. So let's just do a very quick recap. Venn diagram over here. I have my two events A and B, and in this case we call them disjoint sets because they're completely separate. They do not share any of their elements inside. Okay? All the letters together we call the sample space, A, B, C, D, E, and F. Each one of them is an element of my sample space. Then I defined A to be my vowels. It has 2 elements, A and E. And I defined B to be my consonants. It has 4 elements, B, C, D, and F. Calculating my probabilities is always the number in my event divided by the number in my sample space. Okay, and always have your most simplified fraction. Here, when we look for and, it is the intersection. I'm looking if there's a possibility where they share elements. If there are no elements shared, then it's just a 0 in that one. And then A or B is the union, which is all of them together. Okay, and then when we prove or check that left-hand side equals to right-hand side, we do a calculation or show the left-hand side, do a calculation or show the right-hand side, and we show if they are or not equal. In this case, they are equal, and therefore we checked what they asked us to check. There you go. Now it's your turn for number 1, 3, and 4.